Ever felt like your system has enough RAM, yet your games stutter? Textures load slowly, or latency spikes show up in tools like LatencyMon? That could be because Windows is secretly compressing memory in the background, even when you don't need it. Today I'll show you how to disable memory compression, reclaim raw RAM performance, and tune Windows for the lowest possible memory latency. We're going beyond the usual tips with hidden registry tweaks, CMD commands, and RAM scheduler optimizations that most people never touch. As always, before we dive in, create a restore point. These tweaks are safe, but it's smart to have a backup.
Step 1. Disable Windows memory compression, the core fix. By default, Windows automatically compresses memory pages when your system starts running low on RAM. While this sounds like a smart way to manage resources, it introduces additional CPU load and causes latency spikes, especially noticeable in games. In this step, we'll be turning off memory compression for smoother performance. To start, open PowerShell with administrator privileges. Press Win+X and select Windows PowerShell Admin from the menu. Next, let's check if memory compression is currently enabled on your system. In the PowerShell window, type Get-MMAgent. Look for the line that says Memory compression is true. If it says true, that means memory compression is on, and we'll need to disable it. To do so, enter the following command: Disable-MMAgent -MC. After running that command, restart your computer to apply the changes. Once your system has rebooted, open PowerShell again and run the same command, Get-MMAgent. This time, you should see memory compression is false. Disabling memory compression eliminates an invisible bottleneck that affects both your CPU and RAM performance. This alone can help reduce lag and boost RAM access speed, resulting in a smoother experience, especially in resource-heavy applications or games.
Step 2. Disable SysMain, or Superfetch, and Prefetcher. Memory compression often works hand-in-hand with SysMain, previously called Superfetch. This service is responsible for preloading data into your RAM, thinking ahead to improve system performance. However, in modern systems with SSDs and DDR5 RAM, it doesn't really provide the benefits it once did. Instead, it just consumes resources, causing unnecessary RAM churn and occasional slowdowns. To disable SysMain, press Win+R, then type services.msc and hit Enter to open the Services window. Scroll down to find SysMain in the list. Right-click on SysMain and select Properties. In the Startup Type dropdown, set it to Disabled. After that, click Stop to halt the service immediately, then hit Apply to save the changes. Now, let's head to the Registry Editor to make a few tweaks that will further prevent Windows from trying to preload unnecessary data into RAM. Press Win+R again, and type Regedit and press Enter to open the Registry Editor. Navigate to the following path. Once you're in the PrefetchParameters folder, modify these two values. Enable Prefetcher, set this value to 0. Enable Superfetch, set this value to 0 as well. These changes will stop Windows from trying to preload unnecessary data into RAM or performing background optimizations. After making the changes, close the Registry Editor and restart your computer.
Step 3. Expose and tweak hidden memory management registry keys. In this step, we'll unlock low-latency memory scheduling by modifying some hidden registry keys that control how Windows handles memory. These tweaks focus on reducing stutters, improving system responsiveness, and making sure your RAM is being used as efficiently as possible. Start by opening the Registry Editor again. Press Win+R, type Regedit, and hit Enter. Once inside the Registry Editor, navigate to this path. Here, you'll create or modify several D-word or 32-bit values that control key aspects of memory management. Let's go through each one. Disable Paging Executive is equal to 1. This forces Windows to keep system files loaded directly in RAM rather than paging them out to the disk. Paging system files can cause stutters and slowdowns, so keeping them in RAM results in smoother performance, especially in memory-heavy tasks like gaming. Large system cache is equal to 0. This setting disables the oversized system cache. While it might help in certain scenarios like file servers, it can actually harm gaming performance because it uses too much RAM for caching. Setting it to 0 ensures that Windows doesn't allocate excessive cache space, leaving more RAM available for actual applications and games. Non-paged pool quota is equal to 8F in hex. This increases the size of the non-paged pool memory, which is used by kernel mode drivers and system processes. By setting it to the maximum value, 8F in hex, you allow more space for critical drivers, preventing them from stalling or encountering memory shortages, which is crucial for stable performance. I/O page lock limit is equal to. This tweak adjusts the I/O page lock limit, helping with large direct memory access transfers, DMA, which is crucial for tasks like streaming game textures from the disk into memory. And increasing this limit ensures smoother gameplay with fewer texture loading issues or stuttering during intense moments. After making these changes, close the Registry Editor and restart your PC to apply the tweaks.
Step 4. Optimize page file and disable standby memory bloat. Even with memory compression turned off, Windows still relies on the page file and keeps standby memory cached. These mechanisms can cause random stutters, especially during resource-heavy activities like gaming. In this step, we'll optimize the page file and tackle standby memory bloat to ensure smoother performance. Page file optimization. First, we'll adjust the page file settings to make sure it doesn't cause issues with memory management. Press Win+R, type sysdm.cpl and press Enter. This will open the System Properties window. From there, go to the Advanced tab, then click on Settings under the Performance section. In the Performance Options window, go to the Advanced tab and click Virtual Memory at the bottom. Uncheck the box that says Automatically Manage Paging File Size for all drives. This will give you full control over the page file size. Now, set both the initial size and maximum size to match your system's RAM size in megabytes. For example, if you have 16 gigabytes of RAM, set both values to 16384 megabytes, 16 gigabytes times 1024. Why this helps? Setting both values to the same number creates a fixed, predictable page file size. This avoids the dynamic resizing of the page file that can cause performance dips and stuttering. By locking it in, Windows will no longer constantly resize the page file, leading to more consistent memory management.
Step 5. Tune Power Plan for RAM latency. The last step is to ensure Windows isn't throttling memory access with hidden timers. Open CMD admin and run this. This enables Ultimate Performance Mode. Open Control Panel, Power Options, Ultimate Performance, Change Plan Settings, Advanced. Tweak these hidden options. May require PowerCFG minus attributes to unhide. Processor performance core parking min cores to 100%. Memory latency tolerance to 0, force lowest latency mode. System cooling policy to active. Apply changes and reboot. Now your system prioritizes RAM speed and responsiveness over background power savings.
And that's it. You've just killed Windows memory compression and re-optimized RAM handling for lowest possible latency. We went from disabling compression, cutting SysMain and Prefetch, registry-level memory scheduling tweaks, page file optimization to RAM-focused power plans. Now, when you open LatencyMon or jump into a heavy game, you should see fewer spikes, smoother frame times, and more consistent FPS. If this helped, smash that like button, subscribe for more deep dive optimization guides, and let me know in the comments if your RAM finally feels faster.